Okay, so let's get started. We're going to be taking a look at working with our traditional fuel equation mode again. This tutorial, we're going to try to work out what our master fuel value and our table value should be at to have a reasonable starting point for our base map as we're generating it here in our Lynx software to program our G5 and G4X systems. So the traditional mode is a simplistic way to dial in our fueling for our engine. The model mode, we know we have to enter in a little bit more parameters or some math modeling in the background. With the traditional mode, it strips that away. So we're not accounting for things like the engine displacement, the estimated air mass, what the fueling density is going to be, all of that's, again, gone. We are left with a very basic calculation, which is going to be a combination between our, again, master fuel value here and our table values in here. It is going to be multiplying those together to figure out, again, a base pulse width. We know that we have our injector data still added on to that. So the dead time is added on to the base pulse width, and then the short pulse width is added on to that as well to give us an actual pulse width that we pulse the injector at to deliver the fuel into the engine. Now, in this situation, when we get started with the traditional mode, the default value is always here at 15 milliseconds, and then the table values here are something that we don't know. They have to be worked out. Ideally, we'd like to see ourselves at idle, let's say right in here in idle range, vacuum engine speed. We'd like to be around 40, 50, kind of just the similar idea as what we're talking about in volumetric efficiency. And then as we get up here into positive manifold pressures, we like to see ourselves in the 100 to 150 range. Now, these values do not represent cylinder filling, so they're not going to be part of any air mass modeling that we find in the modeled system. It's purely going to be a percentage multiplier to that main fuel value. So if the main fuel value here in milliseconds is going to be lowered down too low, we have to compensate by having a higher multiplier here. Likewise, if the master fuel value is really high, we'd likely find our table values to be really low in order to have that pulse width worked out to be the same, again, in that simplistic math modeling. So again, it's going to be, the equation is the actual map pressure divided by 100 multiplied by the table values multiplied by the fuel value, so the master fuel value here, gives us the base injection effective pulse width. That's our base pulse width. We add the latency of the dead time to that, and then we find that we get our injector actual pulse width. That's what we send to the injector to actually pulse it. So it's a pretty simple equation, and we have some back and forth here. So we know master fuel, lowering it, lowers the overall pulse width, raising it raises the overall pulse width, and then this is going to act as a multiplier to that. But map pressure is factored into the equation, so we have to kind of keep all this into mind. Now, obviously, we don't want to worry about calculating what it's going to be. We want to go ahead and use our Excel spreadsheet that I provided, and I shown in the last training module. The Excel spreadsheet's found in the training course folder. I have that open right here, which is again our master G5 master training course calculator. We have a specific page called traditional. Now in here, we have everything in blue are things that we can edit. Anything in green, yellow, red, or orange are things that are calculated from the spreadsheet. In order to get started here, we want to make sure we're entering some information in here. We want to make sure that the values are going to be what matches our link file to put into the calculator. So for example, my master fuel value is 15 milliseconds currently in my file. Put that here in the blue. Master fuel trim value is 0. I always recommend start off with it 0. Baro pressure, key on engine off, note what your baro pressure is at. You can find that, taking a look at here, as your BAP or baro pressure. So 98.1 is what we find, approximately what I have in the calculator here. Injector latency is your dead time. So we want to enter that in here at 14 volt because that's the average charging voltage we should see in our charging system. So we were operating our injector there. So we're going to see 0.743. Going back into here, we're going to find 14 volt would be 0.743. So that's just what comes from the injector manufacturer's data sheet we would have to enter in here. We want to bring that in. And then lastly, we need to go in and factor in what the ethanol percent is in our fuel system. So I'm going to say I have 10% blended ethanol. I have 93 pump gas, 93 octane pump gas from the local station that's going to have 10% blended ethanol in it. Now, we have our table here. This table is a three-dimensional table. This is a replica of whatever would be in your link file. Now, here's where it gets a little bit confusing, and we have to follow exactly what I'm saying here. In my file, let's jump back in here. This table, if we go under fuel here, that exists is the exact table from the spreadsheet. You want to start off with this table to kind of work out your values. And then we're going to learn how we can edit the breakpoints and rescale and restructure the table that's going to be best suited for our engine. So in order to make sure our table values and the table structuring in terms of the breakpoints are all the same as what I have on screen here, we want to go ahead and right click. I'm going to go here to import from file, go to your desktop or wherever you have your course packet folder saved. I have that right here on my desktop. Go in here to calibrations and then jump into traditional fuel mode. There's a table setup. We want to go ahead and select that, and that's going to bring that table into your link file. And we can go ahead and copy all the values from here. They should match the spreadsheet, just to kind of the blue values that are defaulted in there when you open it up. We're gonna make sure they're the same, so we're gonna go copy it here. We're gonna go in right here, and we're gonna do a copy paste. So we just pasted the data from our table, which is what we imported from the calibration file. All right, so that we're on the same page here. You have all the data the same. So what we're going to find right...
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.